Hello again, Michael Fudge here. This video is the first in a 4-part series on SQL, specifically the data definition and data manipulation commands of SQL. This video will cover all 4 parts of the 4-part series, and then we'll dive into creating tables and inserting data. Let's get on with the tutorial. This series will be broken up into 4 parts. The first part will cover creating tables and inserting data. The second part will cover altering tables using the alter table statement, and we will add different constraints to the tables, and we'll also learn about drop table at that time. The third part will cover data manipulation, specifically updating and deleting data from our tables, and the last statement will cover how we query the schema in the database so that we can find out what tables exist, which columns exist, which constraints have been set. All along the way, we're going to be using the select statement in all 4 parts. Okay, I'm out here in Azure Data Studio, and you can see I already have some instructions up here, and you'll be able to access this data if you want, this code that I'm going to write at the URL provided on your screen above. And you'll be able to then run it in here and use the Learn Databases environment if you want to create your own database. Now I'm going to start out by just talking about what we're going to do here. There's a company, a fictitious company called Spiffy Lube, and Spiffy Lube handles oil changes and tire rotations for its customers. I'm going to start out by just making 2 tables. And if you remember from the first part in this series when we talked about the relational concepts, tables are where we store our data, and our tables consist of rows and columns, and the columns contain the data domain, and that is made up of the physical and the logical domain. So for a customers table, this is a very straw man simple example. For a customers table, I'm going to have an email column. It's going to hold email addresses, and then I'm going to have a first name and last name column. Now, I probably would have more columns, but just for the sake of keeping the demonstration simple, we're going to keep it to that. I'm also going to have another table called vehicles, and then that's going to have a series of columns that we'll talk about in a bit. So first things first, before you start making tables, you need to have a place to store those tables. And you look over here to my left, I have a bunch of databases that are already set up. I'm going to create a new database called Spiffy Lube, and I'm going to use that to store these tables and its data, of course. Create table, Spiffy, fix that. Create database, Mike. I'm already off to a shining start. There we go. All right, so there we go, and I'm going to go over here and refresh, and now I have Spiffy Lube. Now I want to make sure I'm using Spiffy Lube to write when I write my code. I want to make sure it's using Spiffy Lube, so I could say use Spiffy Lube. And you'll notice that it changes my database to Spiffy Lube up here. Okay, Spiffy Lube. All right, now that I've got that taken care of, I might want to make a table. Let's start out and make this first table customers. So remember, the table has columns and rows, and each row is a customer. So I have some sample customers here. Like this is a customer's email, and then his name is Macaroni. So that's just data. And if you look at a table, there's multiple customers in it. So that's why I like to name my tables plural customers. So I'm going to use the create table statement. Create table customers. Now the way the create table statement works is you give it parentheses, and then between the parentheses you put the columns that you want to create for the table. And I'm going to create an email, a first name, and a last name. Now my convention is to usually just use all lowercase. And then email would be, it needs a data type. So this is characters here, so I'm going to call this varchar. Let's do 100 just to give it enough room. And I'm not going to allow nulls here. I want the email to be required, so I'm not going to allow nulls. And then I could create another one. Let's call it first name and that's going to be varchar maybe 50, in case you have a long first name, and then last name. Good. Now, all of our tables should have primary keys, and you could use email for your primary key because this is going to be our business key. That is, no two customers should have the same email, or another way of looking at it as one email should uniquely identify one of our customers. But it's good practice in a relational database to not use a key that you care about or use a business key for a primary key, instead using an integer. So I'm going to use, I'm going to say customer ID, and I'm going to make this an int identity. And int identity means, hey, DBMS, you put the numbers in there. I'm not going to put the integer values in there. You're just going to add them automatically, incrementing them one at a time. Okay, so those are the columns in my table. So this is like the real data, and this is the data that I need to sort of satisfy what the relational model would use in good practice. You don't have to do it. You can do anything you want in practice, but this is what makes for a better table is to use these identities here. That way you can change someone's email address and not have to worry about where else in the database that email address is used and keeping it up to date. These numbers are just dependent on the DBMS themselves, and they have no bearing on the external data itself. Okay, so the last line in here is always to create my primary key. So you would say constraint PK, and then my convention for naming my primary keys is PK, name of table, and then column name. And that's going to be a primary key, and it's on column ID. And so that should make my table. I'm going to run it. And it looks like it went successfully. And if I go over here to Spiffy Lube, there's my table. Now there's no data in it. You'll see it's empty. So let's go ahead and add the data to the table next. We do that with the insert statement. The way the insert statement works is it's basically insert into and then the table name, then the columns you want to insert data into, then the values you want to insert. And the values that you want to insert, I'm going to make them all line up so you can perfectly see. The values you insert should correspond to the list. So let's do the first person here. So let's take that. And then Mac Aroni. All right. And that would do the insert. Now you might be wondering, why am I not inserting the ID? Well, the way I set this up, this is called a surrogate key. And a surrogate key is a value that the DBMS will put in for you. You don't have to put the value in. It'll just add the value on your behalf. And let's just do a select from customers to see what we get back out. So now I don't want to run all of this again. If I run all this again, I'm going to get an error that says you cannot create this table because you already have a table called customers. So there's a couple ways I can handle this. If I want this script to run all at once, I can drop the table customers. Then I can go. Then I can create the table. If the customer may or may not exist, so I can do what's called a soft drop. I can say drop table if exists customers. And now when I run this, it drops the table, creates the table, inserts, and then shows me what's in it every time I run it. You wouldn't do this in practice, but as you're building your database out, this is very handy because you need it. You're constantly creating schema and manipulating that schema. So this is a good way to do that. Okay, and there we go. There's our one person macaroni, and I spelled their com wrong. See that it's little m. So this is a great example of why you might want to write this as an down script where you drop and then recreate the data so that you can sort of fix it as you go. And then when you rerun it, it's going to delete customers, recreate customers, insert, and then show you what's in it. Okay. Now, if I just want to run the select, I can highlight that part and run that. That's another nice feature of most of the tooling that we use to write our database SQL code in. Let's insert two customers. So there's a couple ways I can insert two customers. I can do another insert. And then I can arduously repeat all of this, like so. And then I could put my values in here. And who's my next customer here? Windy Shores. I'm just going to copy the whole thing here. Windy Shores. So that's the first thing. That's their email. Then comes their first name. Then comes their last name. And you can see that I have to put quotes around it because it's actual data. These are column names, no quotes. These are pieces of data, so we use quotes. Okay, and let's see if that works. Okay, so now I have two people in my table. Again, I want to reiterate, every time I am deleting the table, recreating the table, and then adding these two customers to the table, and then showing you what's in the table. When you go to use this in your application, you're probably not going to be in the business of creating the table anymore. The table's going to exist, and then as people, go to your mobile app and sign up to be a customer, it's just going to insert into that table. There's no more creating the table at that point. The table exists and you're being used. But as you're developing the application, you will edit these things a lot. You will be editing the schema a lot as you figure things out. Okay. What if I want to do this all-in-one insert? You can. The dirty secret is you can provide a list of things you want to insert, right? So I say insert into customers. These are the columns I want to insert into. And then this is one of the values. This is the next value. And then let's insert the third value here. I'm going to save this one for later. Let's insert that third value. Chastise is his name. Okay. And we need a comma right there. Now, if I leave the comma off, you see I get the red little wiggle. That tells me there's a problem. If I run it, I'm going to see, incorrect syntax near this. I'm going to click, and it's going to take me right here. I just need to know that I missed something. Like the SQL parser is such where it reads and reads and reads, and it says, this is not what I expect. So usually when this isn't what you expect, it's usually the line above it or the statement before it, which is the actual problem. In this case, it's a comma that I'm missing. These are the little nuances that'll drive you batty about writing SQL code. All right, so there are my three customers. Likewise, let's move on and do the vehicles. Vehicles are actually going to be a little more interesting. I'm going to copy this down here and just paste it so that we have it and I don't have to scroll up and down. Let's do our create tables for our vehicles. So let's do our drop table if exists vehicles. And I'm only doing this right now because I'm figuring out how I want to make this table. Right? And if I don't make it the right way, I want to be able to recreate it. If I make a mistake or there's something I don't like, I can easily have access to a means to remove that table. But again, in standard practice, once your schema is set, you're not dropping tables. Let's create table vehicles. And then always primary key, always surrogate key. This is just the best practice. I follow this all the time. I could use VIN as primary key, but then if some other table has a VIN in it, how do I keep those up to date, right? If I'm using some number that the system generates, then I don't have to worry about keeping it up to date because this number is never going to change. It's immutable. This is always going to be 2. Perfect. That's exactly what I want. This person's email may change. Windy Shores may log in and say, my new email is this, but they're always going to be referred to as ID2. And so I don't have to worry about when Windy, if I made this the key, and Windy Shores changes her email, then I got to go find all of her cars and make sure that those match the email address. Because I'm using an internal ID, I don't. That's the advantage of coming up with your own surrogate. Okay, and then we're going to have a VIN, and a VIN is an ID number, and there could be letters, numbers in it, so I'm going to say that that's a varchar. I don't know how big a VIN is. Let's say 20. And I'm going to make this required, so not null. And let's do make. Let's see, Chevy, Ford, Subaru, 20. If you don't give it enough characters, then it will truncate the characters. If I said varchar 4 and I put in Chevy, you're going to get CH. And then model. Let's go with, maybe models are longer, but let's just go with 20. You can see I can't spell varchar, but that's all right. Still can't spell it. Not null. And I have a 2 in there. I'll leave it as 2. It's broken. Let's leave it like that. And let's move on here and do the last couple. Make model, last visit date. So last visit. I want to make this a date. And let's make that not null. And then we have I forgot mileage. This is going to be a integer. And then we're going to have, it says customer in here. So the convention that you use when you're doing this is when you want to associate a vehicle with a customer, you're going to use the ID of customer here, right? So what I would do down here is I would say customer ID, and it should match type. So it's int, not identity, because I want to put in the customer here. I want to say that is Macaroni's car. This one is Windy Shores' car. And you look up here, I have that not figured out yet, but in the next lesson I will. So we're going to say customer ID int, and I'm going to allow null here because I don't know who goes to what car yet. Okay, let's see what we get here. Let's run just this. Okay, so far so good. Now we need to insert some cars. I'm just going to insert the first 3 cars. We're not going to go crazy here because we've already seen how insert works. So insert into vehicles, VIN, make, model, mileage, last visit, and then I'm not going to insert a customer ID because I don't know them yet. Values. All right, and we're just going to go for it here. VIN, make, model, mileage. Since it's a number, I don't want to put quotes on it. And for dates, we treat them like text, but I usually like to put mine in year, month, day. So year, month, day. I think it was 27, right? Now, what's interesting about the way that this particular DBMS I'm using, Microsoft SQL Server, works is it will parse these dates correctly if you do them this way, too. It's just kind of good like that. It has a default setting that you can use for the date format, and mine is set to crazy US date format, which has the month first, then the day, which is contrary to how everybody else in the known universe does their dates. That's how we like to roll in America, apparently. We like to make things interesting. Okay, so I'm almost done. Good. And let's see, maybe the dates won't go in right, but I think they will. And then let's finish with a select. Whoops, I'm missing a quote somewhere. I gotta. And then let's finish with a select from vehicles. Okay. And it says data would be truncated. See that? Line 65. So in this insert statement, data will be truncated. What data will be truncated? Good luck finding out. This is the beauty of it, right? You just got to know that I'm inserting Outback, and I'm only asking for 2 characters in the model. It's nasty to troubleshoot, but it's got to be troubleshooted. Troubleshot. All right, let's see how that does. There we go. So now I have my table of customers and my table of vehicles. And in the next video, what I will show you is how we can add data integrity constraints in there so that we can't add 2 macaronis in there. And also things like we can't add a mileage that doesn't make any sense, and also a way to connect the customer ID to the customer's table ID through a foreign key constraint. That's what we'll do next.